Hey everybody. Just like most of everybody, I'm not super pro at this, but I'll show you what I've got here. So, doing the origins of mathematics was like my prompt, and it's about Euclid. And Euclid, in the horror genre, Euclid is like non-Euclidean geometry. It's like those big ceilings with all the like stairs that you go like in a doorway and you come out a different doorway and you're like upside down and then you're right side up and then you're walking sideways and it's supposed to make sense, but it totally doesn't. Euclid makes sense of stuff. That was what he did. He lived like a long time ago in around 500 BCE, which is before Common Era. So the closer or the bigger the number gets, the older it was. So he lived like 500 to 430 BCE, something like that. This is just a painting of him because there's not really a lot of records of the dude. He like was a ghost, but we know about him because a lot of his contemporaries and people after him also like kept referencing him, and they quote his work, and he's got a lot of stuff written down, lots of notes and stuff. So that's how we know he existed. He was around the time of Archimedes and Ptolemy, stuff like that. So what Euclid did though was super important because this was the world like way back, and most importantly here, not so much the Americas, but in Europe and in China especially, there's a lot of different ways that people did math, and there's a lot of different ways that people expressed math, and the way that we computed stuff. And so he went around and he's known for his geometry, like I said before, but his biggest work was compiling all the information and then getting all the stuff that matched up the same and then kind of like standardizing it. And then he wrote it all down and then he published it, and they had a lot of people copy it and they redistributed it. And that was called his Elements. Like I said, it's more meaningful than his contributions. It united math. It also had his axioms, which I'll get into here in a second, and also laws of expression and self-evidence. So specifically, he had these things that he called axioms, and they would postulate stuff. They'd say things like, you can make one point and draw a line to any other point, is a really good example. And that's just like that sentence as a provable law, provable and not disprovable, kind of sets the stage for how math is done and how we do math going forward for the rest of, forever. Because you can't, if assuming that there was no walls that could block your line, you could make a point in my kitchen and a point to your kitchen wherever you are watching this, and you could draw a line to it in a straight line. No curves, no bumps, and that's irrefutable. And that is also something that he gets into with self-evidence, is there are certain things that he can say, that we can say about math, that is not necessary to provide proof, like the total of something is equal to the sum of its parts, like 1 plus 1 equals 2, and if you take 2 minus 1, then it's now 1, and stuff like that. Or if you take two equals and you subtract equals from it, then it remains equal, stuff like that. A little bit complicated, but not too bad. But then, going back here, I almost forgot. So it's argued in Avarides, Euclid's Contributions to Mathematics is where this is all coming from, by the way, in case that matters. And then in here, in the Mathematics of Harmony, this is where they really get into linear postulates, making graphing, standardization, and law beget more advanced computation. This is really talking about how Euclid's contributions to math and standardization of math basically made computers possible. And the self-evidence and rules of law about math and stuff, and postulates and mathematical union beget the origins of computation. That's really specifically about computers. And that's what this whole book is talking about, really. They just get into how if it wasn't for that and what laying a foundation for future researchers and future mathematicians, that computers and stuff wouldn't have even been possible. And that's basically it. That's what he did. That is how we got here. Like I said, Euclid did a lot of stuff with geometry, which matters. But the main things he did was standardize math, take a bunch of other people's research, and most importantly, wrote it down and made lots of copies and passed on his teachings so that, generation after generation could build upon that and get us to where we are. And this is, we're excited. Some of this is just for images, but the main ones, are Euclid's Elements of Geometry, the Harmony, which is about math, and then Euclid's Contribution in Math. And this is, Alvarides' work is really just getting us beyond the geometry contributions is all. So anyway, guys, this is probably pretty dry to listen to. I know I wouldn't want to listen to it personally, but thanks for watching anyways. And I'll be watching yours. And so have a good evening or a good week. And thanks for having a good semester. Bye, guys.